So the RTDs are offered with 2, 3 or 4 lead configuration. The best configuration for a specific application depends on a number of factors. However, the sensor configuration must match with transmitter, otherwise lead wire resistance cancellation circuitry may be ineffective. So types of the RTD constructions are 2 lead construction, 3 lead construction and the 4 lead construction. So let's talk about these three categories in brief. So the two-wire construction. Two-lead constructions result in lead wire resistance getting added to the element resistance. Consequently, the temperature reading is artificially high. So you can see here the diagram, two-wire connection. Two-wire construction is the least accurate of the three types since there is no way of eliminating the lead wire resistance from the sensor measurement. Also, the two-wire RTDs are mostly used with short lead wires or where closed accuracy is not required. Let's talk about three-wire construction. You can see here one image of three-wire connection. Three-lead constructions result in cancelled lead wire resistance error only if the transmitter can measure true three-wire resistance. Lead wire resistance error cancellation is most effective when all the lead wires have the same resistance. Using three wires of the same average length and composition will typically result in lead wire resistances matched within 5%. So let's talk about where three-wire RTDs can be used. Three-wire construction is most commonly used in industrial applications where the third wire provides a method for removing the average lead wire resistance from the sensor measurement. When long distances exist between the sensor and measurement or control instrument, significant savings can be made in using a three-wire cable instead of a four-wire cable. So you can see here four-wire construction. Four-lead constructions result in cancelled resistance only if the transmitter can measure true four-wire resistance. True four-wire resistance measurement will effectively cancel lead wire resistance error even if all four wires are not the same average length and or composition. Also, where four-wire can be used, so four-wire construction is used in primarily in the laboratory where close accuracy is required. So in a four-wire RTD, the actual resistance of the lead wires can be determined and removed from sensor measurement. So let's analyzing further for these three categories of RTD wires. So guys, you can see here three different types of RTD wires, 2-wire, 3-wire and 4-wire. So in this video we will further know about the 2-wire, 3-wire and 4-wire RTDs. So first of all we studying 2-wire RTD and also we cover this why we don't use 2-wire RTD for the long distances. So you can see here one diagram. A and B here is lead wires and which is attached with Western bridge. So as we know, at bridge balance condition, current through galvanometer becomes 0. For this concept, you should know about Western bridge concept. So at bridge balance condition, R1 is equal to R2 and R3 is also nearly or equal to 0. So for this, first half of the bridge is equal to the second half of the bridge. So for that, R1 plus R3 is equal to R2 plus B plus RTD plus A. So is equal to R2 plus B plus RTD plus A. So first half of the bridge is equal to second half of the bridge as per bridge balance condition. So now R1 and R2 get cancelled due to R1 is equal to R2. So now R3 is equal to A plus B plus RTD. So the lead wire resistance is added with the RTD, which may gives the errors. So due to these errors, we don't use this 2-wire RTD for long distances measurement, which cannot give the accurate results. So now we will talk about the 3-wire RTD. As you can see, lead wire value is added in 2-wire RTD so that it may give errors. So that case will compensated with 3-wire RTD by applying extra lead wire. You can see here RTD is connected with 3 lead wires A, C and B with Western bridge. By applying bridge balance condition, we adjusting R3 until the galvanometer current becomes 0. So for this balance condition, R1 is equal to R2 and the first half of the bridge is equal to second half of the bridge as per bridge balance condition. So now R1, here you can see R1 plus R3 plus A plus C. This is first half of the bridge and the second half is R2 plus B plus RTD plus C. So R1 plus R3 plus A plus C is equal to R2 plus B plus RTD plus C. Now R1 and R2 get cancelled due to R1 is equal to R2 and also C and C are cancelled. So R3 is equal to RTD plus B minus A. So here as we know A is equal to B is equal to C because these 3 wires are same lead wires. So A is equal to B is equal to C. That means B minus A is equal to 0. So R3 is equal to RTD because B minus A is equals to 0. That means so 3-wire RTD can be used for long distances because it can remove the errors like this. So it can remove the errors in long distances while measuring element. So now we will talk about 4-wire RTDs. You can see here the 4-wire RTD sensor. So let's talk about this. So here you can see 4-wire RTD which is used in 2 configuration. It uses triple pole double throw switch. Its 2 configuration is switch in position A and the switch in position B. When the lead wire A measured with the RTD in switch in position A and the switch in position B like the lead wire B measure with RTD. So this 2 case for 4-wire RTD. Let's see. So from the bridge condition, first half of the bridge is equal to second half of the bridge. So here R1 plus R3A plus C is equal to R2 plus B plus RTD plus C. So R1 plus R3A plus A plus C is equal to R2 plus B plus RTD plus C. Okay, so here R1 and R2 get cancelled due to R1 is equal to R2. Also C and C got cancelled. So here R3A is equal to
RTD plus B. So this equation is A. Now we will move on to the second one. So here first half of the bridge is equal to second half of the bridge is R1 plus R3B plus B plus D is equal to R2 plus A plus RTD plus D. D is equal to R2 plus A plus RTD plus D. Now D and D got cancelled. Also R1 and R2 get cancelled. So R3B plus B is equals to A plus RTD. It's B. Equation B. And from A and B equation we got the result is RTD is equals to R3A plus R3B by 2. So this is the main formula for 4-wire RTD. So this 4-wire RTD can be used for more accurate results of temperature measurement, majorly in laboratories where main accuracy is needed. So 4-wire RTDs are more accurate as compared to this 2-wire and 3-wire RTDs.
So, talking about its advantages for RTD, so it is more accurate than thermocouples. It has stability, more stable, good sensitivity, zero point 0.1 to 10 ohm per degree Fahrenheit. So, in conclusion, we conclude that the difference between 2-wire, 3-wire, and 4-wire RTDs, 2-wire lead wires resistance is added into the RTD, so it is not useful for the long distance temperature measurements. The 3-wire RTDs are removing the average lead wire resistance from the sensor measurement when long distance exists between the sensor and the measurement control instrument. And the 4-wire most commonly used for the measuring more accurate results for temperature in long distances like laboratories. So this is a basic concept of RTD wires, which is 2-wire, 3-wire and 4-wire. If you have any query